Hi, my name is Phil Whiteman. I'm a senior network engineer here at Laketec Communications. Today I would like to show you a high-level overview of the SD-Branch solutions, features, and functionality. So without further ado, let's get started. So I said SD-Branch. What is SD-Branch? SD-Branch is a combination of wired, wireless, and SD-WAN all in one solution, all one pane of glass, all one place where we can do configuration, monitoring, visibility, alerting, etc. When we hear the industry term SD-WAN, that would be focused on one particular appliance. The SD-Branch gateway would be the equivalent of an SD-WAN appliance for the industry standard. So with that said, let's kind of take a look at these different components that make up the solution. So I'm going to go into my branch location here because I like the topology view. I think it helps us break this down much better. So as you can see from the view here, we have several different components. At the top here, we have our VPN concentrators that sit in the data center, followed by our SD-Branch gateway, SD-WAN, followed by our switching architecture, and then our wireless architecture. So from the data center side, like I said, this houses our VPN concentrators. VPN concentrators can be deployed in several different fashions. What we have here is we have a redundant pair of concentrators in our primary data center and a single VPN concentrator in our secondary data center. We could deploy dozens of data centers, dozens of VPN concentrators, and they don't have to be paired up. They can be single concentrators or a pair of concentrators. We can also set precedents on which data center should be the primary path for any particular branch or location. We can also set precedents on which VPN concentrators will be the primary concentrator for any particular branch or connections. So as we see here, the VPN concentrators can terminate multiple WAN interfaces. So they can terminate MPLS, Metro E, broadband circuits, etc. From the moving down to the branch perspective, the branch gateway itself can also terminate multiple WAN connections. Each branch gateway can terminate up to 4 different connections. Again, same thing, Metro E, MPLS, broadband circuits, also has LTE. The newer branch gateways have a built-in LTE radio. And we can deploy a redundant SD-Branch gateways or gateways into a branch location. And these gateways can share each other's WAN connections. Typical use case for that would be oftentimes an MPLS circuit is delivered with a /33, so you can only terminate it delivered with a /30, which you can only terminate it on one branch gateway. So the branch gateway that doesn't have the MPLS circuit can route traffic through the other branch gateway to take advantage of that MPLS circuit. And typically, SD-Branch is deployed with multiple circuits, so if you lost that one branch gateway, you still have resiliency with the second branch gateway. You just may not have your MPLS circuit, but you'll have the other circuits that will be available to you. The design supports BGP, OSPF, dare I say it, RIP, static routes, connected routes, anything you would typically see on a fully built out router. Stepping down to the next piece of the solution would be your switching environment. So here in my particular branch, I have a switch stack with two 2930s in the stack, and then I have a wireless cluster here as well with 2 APs in this particular branch. So the SD-Branch solution could be just a couple components of this, or it could be all components. So at a minimum, you need a gateway, and you need the VPN concentrators to at least do your IPsec tunnels to each of the locations. So as you see here, these support multiple IPsec tunnels. So for each WAN circuit, I have an IPsec tunnel pinned up to each one of my VPN concentrators. And then I have that for both my WAN circuits. And we'll talk about how these dynamically get spun up a little later on. And by the way, from this screen here, we could take a look at some statistics of any of the particular devices in the branch here, which is kind of cool. So let's talk about basic configuration within SD-Branch. So up in the upper left-hand corner here, you can see we have a bunch of different types of categories. So the branch solution can be configured so that we have a a group level configuration, which we have all of our configurations which would apply to every single branch. So in this case, say the gateway itself, we would configure group level settings to maybe specify SNMP servers, NTP servers, just all your standard configurations that would apply to all branches. And then when we bring in a particular gateway into that group, we would then configure gateway-specific settings like a host name or a system IP address. And we would do the same thing. We'd create a group for our virtual controllers, and we'd create a group for our switches. So this allows us to have the vast majority of our configurations at the group level, enabling us to efficiently and speedily deploy the different parts of the solution. We're not going to talk about it today, but all of these can be configured via zero-touch provisioning. So a device comes up in a branch location, it'll automatically call out to Central, find its group-level configurations, bring those down, find its specific configurations, bring those down, and its firmware, etc. We'll cover that in a different video. But that's how the configurations look. We have group-level configurations, and then we have device-level configurations. The sites itself, we can then put together all of the components, like my orange site here. I can put together my switches, my virtual controllers, and my gateways into a site configuration. So we have a view for alerting, monitoring, etc. from that standpoint. So one of the major features that I alluded to a minute ago would be the configuration of the IPsec tunnels. So let me get to that here. So if we go into our gateways, we go into our configurations, we go into our VPN configurations. So Aruba has a technology called Orchestrator. So Orchestrator has the ability to, again, dynamically pin up IPsec tunnels to the appropriate VPN concentrators and across appropriate circuits. So the way that works is the VPN concentrator in this environment, we have it configured for BGP so that we can learn all of the corporate networks. When we learn all the networks via BGP, those are redistributed into the technology that we're calling Orchestrator. So Orchestrator now knows about all of our corporate networks in any site, so any one of our data centers that has a VPN concentrator. So it knows what networks are where. From the branch gateway perspective, we can do the same thing. So whether we're running dynamic or static routing protocols in the branch gateway, in the branch itself on the gateway, those networks are also redistributed into the orchestrator. So in my particular case, we have all commodity circuits and you could, I guess, have one MPLS circuit in that location. And all of those connected routes, as well as any static routes for the MPLS, would be redistributed in Orchestrator. So Orchestrator then takes and learns on both sides where those particular networks are and what circuits are behind. So it will dynamically pin up an IPsec tunnel between an MPLS circuit in the branch and the MPLS circuit on the VPN concentrator. And likewise, it'll do the same thing for Metro E. And then commodity internet, it's pretty cool because you can actually give the commodity internet a label. So like maybe I have one that's AT&T, I have one that's Spectrum. And I have that both on the VPN concentrator side and the branch side, for example. So the orchestrator will pin up the IPsec tunnel between AT&T and AT&T, or Spectrum and Spectrum. If one end or the other doesn't happen to have that particular provider, it knows it's an internet circuit, so it'll go ahead and pin up the VPN tunnel, even from an AT&T to a Spectrum. But it's going to try to prefer to pin them up across the same provider to get you a better experience for your tunnel, which I think is very handy. We can also set a data center preference here. So as you saw in the video diagram, we had one our preferred data centers, our data center 1. We have 2 VPN concentrators in this data center. So the orchestrator will pin up VPN tunnels between these, but it's also going to give some weighted routes to these. So this might be a cost of 10. Well, this would be a cost of 10. This would be a cost of 20. And then our tertiary data center or our tertiary VPN concentrator would be a cost of 30. And that's okay because we set these preferences ourselves, and we will have IPsec tunnels built up to all of these. So if we lose an IPsec tunnel or we start seeing degradation in the performance of that tunnel, we will shift over to the next VPN concentrator, the next circuit. We'll talk about that here in a second with dynamic path steering. Before I go there, we can also enable or disable branch-to-branch communications, which is fairly nice. So dynamic path steering. So this is a technology that allows us to look at certain traffic, apply or look at an SLA, and then send it down a certain path. So because we have multiple WAN circuits and we have multiple IPsec tunnels and just direct internet access, we have lots of choices for where this traffic can go. By default, we want to keep all of the routing metrics to default settings. So we don't want to, traditionally we might have influenced a certain metric for voice traffic so that we could make sure it goes over a certain path because it has a better metric. So instead of doing that, we can now do it in a more dynamic fashion with what we call dynamic path steering. So let me show you an example of that. So I'm going to create one on the fly here. We'll pick on voice still because voice is a pretty common application that we want to pin to a certain path. So policy name, just going to call it voice, and then we're going to we have to match that traffic. So what does the voice traffic look like? In my case, I'm going to match it to this alias that I've created that has all my voice networks already combined in this alias. So this alias could have not only the networks, but it could also have maybe the voice gateways as host addresses inside that alias. So I'm going to match the traffic on its destination. Oops, there. Now I'm going to match the traffic on its destination with the voice alias here. Or we could have just left this any, and then maybe done an application or port where, the application would be, port 5060, which would be our voice traffic. So we're just matching on a port there. So I'm going to leave it on the networks. So I'm going to save that there. So we've defined a traffic match, and now we're going to define an SLA. So an SLA, you can't see my drop down here because of my recording software, but there's several built-in SLAs. I'm going to pick the voice SLA out of the list here. You can see it's pretty fine. So it says, so basically what this is saying is that any traffic that we're matching needs to have a latency and jitter stats that match these values here. And if they match the values, which I'm going to leave this on best for voice, then I'm going to have it go down a specific path. So in my case, I'm going to want it to always traverse my MPLS circuit because I know the jitter and latency is going to be low. It's always available, so that's going to be my primary path. However, maybe I had a couple primary paths which are very solid or very stable, so I could configure maybe my MPLS and my Metro in here. So what this would do under this configuration, it would actually load balance these sessions between these two circuits. If you had a reason to do so. I'm not going to do that. I'm going to just say I always want you to go down my MPLS path if it meets the SLA. However, if it doesn't meet the SLA, I want you to use the Metro circuit paths as your secondary preference. So we can add this in here like this. And my tertiary path, maybe I want to send it across a broadband internet connection, which of course would go across IPsec, but it's just traversing the internet as my tertiary path. So, if the SLA is met, it's always going to choose its primary path. If this degrades, it's going to choose a secondary path and tertiary. If this one fails, but as the SLA starts improving and starts meeting its metrics, it will then wait some timers to prevent some flapping of traffic, and it will start sending the traffic back down the primary path when it starts meeting its SLA. So very cool there. So I'm going to go ahead and finish this off. So I just created a policy to say all my voice traffic gets pinned down a certain path based on my preference, and we're always monitoring for jitter, latency, and all that, which I'll show you here in a second. Again, we could do any custom application. So we could have done either a custom application or some built-in applications to check for the traffic. Like Office 365 is a built-in application, which I might want to create that to set all my Office 365 traffic to just straight out the internet. So you can't see these drop downs, unfortunately, in my recording software, but Office 365 would be one of the applications that we could monitor, set an SLA on, which may be just best for internet, and then choose which path it's going to go down. And we could repeat this for anything that we need to choose a particular path for. If we don't choose a path for this, it's going to follow the normal policy-based routing and routing tables that are installed on the routers. But this will influence which path it goes down to before handing it off to the routing table. Again, very cool. So what does that look like? So how do we see the latency and jitter and all that? So let's take a look specifically at my branch gateway. and we'd see some real-time statistics being plotted here. All right, so I'm looking at the summary of my particular branch gateway, and as you can see here, we're looking at both WAN circuits. We can see the 3 VPN concentrators and their availability, and we can see some other health stats. But what I want to look at specifically here is the WAN. So on the WAN, now we get we can pick our interface specifically to look at. We can take a look at the health checks that are running across each one of the different circuits. So a default gateway is a health check, literally to the default gateway of the gateway. Health check IP. This is just an IP out on the internet. Actually, Aruba provides, so we can run health checks to a specific IP on the internet. You can put a custom one in there if you like. Excuse me. And then, of course, we're monitoring the experience across each one of the VPN concentrators. So we can see our throughput here, WAN utilization for internet, VPN, or everything. And we can also now take a look at the latency, packet loss, jitter, and MOS score. So we can write SLAs to match, one or a combination of these things, as you saw just a second ago. And we can also look at these. Again, it's monitoring all circuits all the time, so it knows what the SLA looks like on each one of these circuits. So if the MPLS connection over to VPNC 1 doesn't look good, it's going to then start sending the traffic over the MPLS connection over to VPNC 2 and so forth. And then, if the MPLS connection maybe in the branch location is completely failed, it's obviously not going to pass its latency, or the latency is occurring on the branch gateway side. It's, based on what we picked, it's going to send it over to the Metro E and monitor these same statistics. So very cool there. And actually, while we're on the screen, all of these devices, I happen to be in the branch gateway right now, but all of these devices we can reboot remotely. We can also open up a console directly to them. So as if we're on site, we plug in our console cable to get CLI access. We could do that directly from Central now. So we don't have to have IPsec tunnels pinned up for this. The device at least needs to be reachable on the internet, and we can get console access to the device. So very cool. Same full command set that we could run if directly connected to the device. Another really nice feature here is firmware compliance. So we can keep the particular gateway or switch or wireless controller under a certain firmware compliance. And what's really cool about this is that we can schedule upgrades. So let's say maybe 8. I don't know what version just came out. Let's say 8.5. Whatever just came out. We could schedule this to upgrade a particular branch location or all branch locations on a certain date and time, which is very, very nice, and an auto reboot. So, and again, we can do this specifically for wireless or specifically for the gateways or the switches or all of them. And then we can specify the time frames individually as well. So very nice there. Okay, so one other really cool thing I want to show you is that these devices also have fully stateful firewalls built in. So if we look back at, I'm still under my branch gateway, we could take a look at every single session that is traversing that branch gateway. So, any port, any protocol, we will record here, we'll see here semi-real time, and we can take a look at the details here. What's really cool about this is that because we have this visibility, we can wrap firewall rules around any of this traffic. And we can, furthermore, apply those firewall rules, what we call user roles, which I'll talk about in a different demo. But it's basically when somebody authenticates either on a wired switch port or authenticates on wireless, they can get assigned a user role, and that user role can dictate what they can and can't get to, apply bandwidth contracts, etc. So very powerful there. So the branch gateways have a fully stateful firewall, as do the wireless controllers. They also have a fully stateful firewall. So if we're going to jump over to one of my controllers here, we can take a look at all the applications that are traversing wireless right now, and there you are. So very cool. And this here is actually showing some statistics on usage, but we can also see percentages, categories, everything there. We could see all the clients that are connected to wireless. We could also see clients that are connected to wired if I had wired authentication configured on my gateway, which I don't at the moment, but when I do the next video, we'll definitely show that. So that's about it. I wanted to show you guys, some of the features and functionalities of SD-Branch. In later videos, we'll take a little deeper dive into any of those particular areas. I think, like I mentioned, I'm going to do another video on user roles and how we can authenticate wired devices to keep people from plugging into your your data jacks right there in your waiting area or whatever, and and not allow them on the network. Whereas other things that we're plugging into your wired network can get dynamically recognize what they are, like a video camera, and dynamically provision with a VLAN and an ACL based on what it is. Unplug that camera, plug it in a different switch port, the whole thing's going to happen again. So everything about it is very dynamic, but I'll do that in another video. So I hope you got a little bit out of this. Thanks for your time. Appreciate it.